Can we give a round of applause for Ondřej?
So if you have any questions, you can come to the table with the elephants in the sponsor area. Can you hear me well? Does the microphone work? Okay, perfect. So thank you for the introduction. And the first question I have for you is, are you already using PHPStan? Yeah, almost everyone. For those few, I also see a PHPStan t-shirt back there. Perfect. So if you are not yet familiar, it's a static analysis tool focused on finding bugs in your code. So it's kind of a stand-in for a missing compiler in PHP, because PHP is an interpreted language. So if you have some kind of mistake, like access to an undefined variable or calling to an undefined method somewhere deep in some kind of condition that's not often executed, without a compiler, without static analysis, you would find out about this error when the line of code executes, either with your automated test or in production in the worst scenario. But PHPStan is going to scan your whole code base for these kinds of bugs. So you can uncover these tricky bugs even if they are not, even if you don't know about them today or during development. It's a free open source tool. You can run it on the command line and the output looks something like this. So here you can see that it tells you that this method is supposed to return string but returns an integer, or that you have a typo in the message in the method that you are calling on an exception. And PHPStan uses everything that's available to it. So it uses native return types, it uses also PHP doc types. You can even express things that you cannot express in native types, you can express them in PHP doc types. So for example, if your method should only accept positive integers, you can type into PHP docs, and if some piece of code that is calling this method doesn't make sure that it's calling it with a positive integer, PHPStan will also point this out as an error. And today I want to talk to you about writing custom rules so that you can find bugs that PHPStan does not report out of the box, but that are specific to your code. So you can actually implement some extra functionality for PHPStan on top of what it already does. So the motivation for custom rules is that it makes code reviews easier. So who is doing code reviews? Hopefully everyone, perfect. So it can be very tiring to be pointing out the same mistakes over and over in the code reviews. And the idea with custom rules is that for those common mistakes that are happening over and over, you can implement an automated check that is going to run in CI, and the pull request, the branch should come to a human reviewer after the CI is green, right? So CI is going to point out all these mistakes that are covered with automated checks. And when the code reaches human reviewer, it's already going to be free of these mistakes. So that's the idea behind custom rules. Custom rules can be also made to prevent bugs and production incidents. So every time you have a bad incident, bad bug that got into the production, you should look at the code and think about if this was possible to uncover with a custom rule just by looking at what the code does and how does it work, if it's possible to automate it with PHPStan. And you should do it so that the bug does not happen next time. And you can also achieve consistency and code quality with custom rules. So usually, if you are using some kind of framework like Symfony, Laravel, or even PHP Unit, there are usually multiple ways how to achieve something when you are using the framework. And usually your team is going to prefer one way over the other, and you can write custom rules to actually enforce the best way how to achieve something. So for example, in PHP Unit, I see Sebastian sitting in the first line. You can have multiple ways of asserting whether some value is true, right? You can call assert same with true and the actual value, or you can call assert true with just a single argument, which is more readable, and PHP Unit is going to have better error messages. And this rule is actually already implemented in the PHP unit extension for PHPStan, but I just wanted to let you know about an example of what you can enforce with custom rules. And who is already using coding agents to write their code in the age of AI right now? Yeah, a few hands are up. So I think that you can write custom instructions in, for example, Claude MD file, right? But it's not really enforced. The agent will read these instructions, but you cannot be sure that it's actually going to follow them, right? It can fall out of the context window and so on. So I think that enforcing things with custom rules is actually much more efficient, and it's going to be deterministic instead of just writing some vague instructions into Claude MD file. So that's another thing that these custom rules are relevant for. Okay, so this is the motivation. Without custom rules, without some kind of automated check, you need to rely on the fact that the person, the developer working with your code, is going to read the comment, right? You have class person, and the constructor says that you should not instantiate new person directly. You should instead use person factory. So if someone is working with your code, you rely on the fact that they are going to read this comment and they are going to follow it. But of course, this should be enforced with a custom rule. The idea behind this comment is probably that person is a value object. It does not have access to services registered in the dependency injection container. And for example, one thing that person factory can do is to check for username uniqueness. It can validate email and so on, which is something that person cannot do. So you want to enforce that every new person entity created in your application goes through these enforced checks. So you want to use person factory everywhere. So this is what custom rules boil down to. We want to report something that's valid PHP, because this is perfectly okay from the point of PHP, because as long as the class exists, as long as the constructor is public, as long as it does not have any required arguments, this is valid PHP, right? But it's not valid in our project, because we want to use person factory. So we want to flag this code as wrong. Everybody understands why we want to implement this custom rule? Perfect. So the way PHPStan works is with something called the AST. Did you hear about this term already? Yeah, some of them did. Some of you did. So it's a representation of the source code of a PHP file. It's a tree of objects, and for example, it looks like this. So we have this expression, and it's a Boolean AND. It checks whether both of these sides are true, right? So on the left side, we have a property fetch, and the AST is going to tell us on which expression is the property fetched and the name of the fetched property. And on the right side, we have a static method call, and the AST can tell us what's the name of the class that the method is called on, and what's the name of the called method. And this is what PHPStan internals and what your custom rules work with. So if you are familiar, for example, with PHP Code Sniffer, who has ever written a custom rule for PHP Code Sniffer? It works differently, right? It's based on tokens, which is just a flat array of values, and you need to interpret it yourself. So for example, if you PHP Code Sniffer rule will tell you that it encountered, for example, this, but you need to look around to figure out whether it's accessing a property, whether it's calling a method. and so on. So you need to kind of parse and interpret the tokens array yourself. But on the other hand, PHP code sniffer gives you access to white spaces. So you can use PHP code sniffer to implement formatting rules, like is this curly bracket supposed to be on the same line or on the next line, and so on. PHPStan does not give you this. PHPStan is only interested in the code semantics, in what the code does. So, but on the other hand, it's much easier to implement rules about code semantics in PHPStan. So, PHP code sniffer or PHP CS fixer are still relevant. You can use them for code formatting rules, but if you're interested in what the code does, it's much easier to write PHPStan rules. This is the library that PHPStan is using for representing the AST. It's from Nikita Popov. It's called PHP Parser. And if you visit, you don't need to look at the classes in your IDE. You can visit API ref, like API reference.phpstan.org, and here's generated documentation for the PHPStan API, but also for PHP Parser API. So you can see all the AST classes that are in action when interpreting, when parsing and representing your code. So you can see the class names here, and they are quite familiar, right? Each of them represents a construct, a piece of code that you can write in PHP. So we have a break, we have catch, class construct, and so on. So they are quite familiar, and they are all used. There are dozens of them, and they are all used to represent everything that's possible to write in your PHP code. If you want to implement a custom rule, you need to implement this interface, and it has two methods. Get node type. We need to return the class of the node that we are interested in from PHP Parser, and every time the analyzer encounters a node of this type in your code, it's going to call the second method, and it's going to pass the node as the first argument, and the second argument is something called the scope, which I will be talking about later, and you are supposed to return an array of errors that basically what's wrong with the node that was passed in the rule. So now is the live coding part. Hopefully it's going to go well, and we will write our custom new person rule. So I prepared some code here. We have person factory, and we have this file. So this is the code that we want to report as wrong, and we need to implement the rule. So I will create new person rule. I will copy the namespace. Today I am very lucky that PHPStorm is able to autocomplete this, because the files come from a far file, PHAR file, and sometimes PHPStorm forgets about these. So I have to invalidate the caches and restart the IDE, and then it works again. So now everything is fine and it works. And I will implement those methods. And don't know why it doesn't like this. Yeah. And I also need to register the rule. So I will open the phpstan.near file, and I will add it here. So if you are just starting with custom rules, if you are writing your first rule, you have no idea what to put here, right? Because you are not familiar with the PHP parser, with the AST classes, and so on. So my first tip is to just hook onto all nodes. So this is the interface that all the classes have in common. So you can hook your rule onto that, and we can just var dump. Hopefully Derek isn't here. You can also use xdebug, but just for the purposes of this talk, I'm going to just use the easy var dump, and we will see what it does. So I will run it only on a single file, src test.php, and my next tip is that you need to use --debug, which is going to do two things. It's going to only run in a single thread, so we are actually going to be able to see the output of the var dump call. Otherwise, PHPStan is parallelized, so it runs in multiple threads. And also it's going to disable the result cache, which is very useful when you are developing a new custom rule. All right, and now we can see it. Can everybody see it well? Perfect. So if you look at the output and you look at the structure of the file, you can kind of follow what's happening here, right? So also there are some nodes that begin with PHPStan namespace. They are called virtual nodes, and I will also mention them later, so we don't have to worry about them now. But if you only follow the PHP parser nodes, you can see that we have a namespace here, we have a class, we have class method, expression, assign, variable, new. So this is probably the thing we are interested in. So now we know what kind of node we have to write we have to return from the getNodeType method. So we will use this. And if we look at how the new class looks like, it has a class and it has arguments. And class can be three different things, which actually covers everything that's possible to write in PHP. So this is name. But you can also do something like this, right? That would be the expression case. And you can also write anonymous classes. So that would be the class case, okay? But right here we are only interested in the name. So it does not autocomplete because the IDE kind of doesn't make the sense of that this type is going to be here, but we can help it with generics, and because this interface is generic, we can say what's going to be the node type. You can see that this interface is generic, so we can say that this is going to be a rule for the new node type, and right now the ID can autocomplete. It works. Instance of, and if it's not a name, we are going to return early, and we are going to get the class name. And if the class name is not a person, we are also going to return early, and now we can return the error. And in PHPStan 1, it was possible to just return plain strings here, but I removed that option, and now you have to return instance of rule error. And the easiest way how to obtain an instance of rule error is to call rule error builder with a message. New person is not allowed, and we call build to get the instance of rule error. New person is not allowed on line 10 here, so this works. And you should also analyze, when you write a custom rule, you should also make sure to analyze the custom rule with PHPStan. So if we analyze the whole project, you will see some problems here. So in our rule that we have just written, PHPStan is complaining that we are supposed to return identifier rule error, but we only return the rule error. And there's a helpful tip here, which says that the error is missing an identifier. So we have to assign an identifier. And identifiers have been available for quite some time. And they can be used to ignore errors, and they usually look like this: something dot something. So we can assign an error here, and we can say PHP UK new person. So it's no longer complaining in the rule. Of course, the only valid usage of new person is in person factory. So we can ignore it here. And it's no longer complaining. But the nice thing why I introduced the rule error builder is because you can attach more information here. For example, you can make the error non-ignorable. So you can no longer you can no longer ignore this error. You cannot baseline this, and you cannot error this. So if you want to make sure that your colleagues do not misuse ignoring errors too much, you can make your custom rules non-ignorable like this. So I wanted to show you that. Okay, so we still have this problem. We need to take care of this, and we actually need to allow this when we are in person factory. So I will switch back to the slides, and I will tell you about the second parameter of the process node method, which is called the scope. And scope tells you everything that PHPStan knows about in the code, in the place where the node is present when it was encountered. So it knows about the file, the namespace, what class are we in, if we are in a function or a method. It knows a lot of things about the code, so you can ask about it. So we will switch to writing the code again, and we will ask the scope about whether we are in the person factory. So if scope is in class, we will get the class reflection, and you can see that this returns a nullable object. It can either be class reflection or null. But because we first called is in class, which has this helpful annotation. Who has ever used PHPStan assert or something like that? Yeah, quite a lot of people. That's great to hear. So if you are guarded by this condition, PHPStan already knows that this cannot be null, so we don't have to check it again. And if the class is Spencer factory, we can return early. And now all of this works, and we can see that the error in person factory disappeared, and we only have the remaining one, which is actually be expected because we are not supposed to do this. Perfect. I have another idea for you, which is about disallowing comparing datetime objects with 3 equal signs. So datetime is one of the classes where this can actually be okay, because PHP implements comparing these two classes together, so you can actually compare them with 2 equal signs, and it is going to return true if they represent the same time down 2 microseconds. But if you compare them with 3 equal signs, it's probably a mistake, because it's only going to return true if these two are references to the exactly same object, which is probably a mistake in case of date times. So if you ever encounter this mistake in your code, you would probably appreciate a custom rule about this. And this is where this method getType is relevant, because it can give us type of an expression in the place of the code where we are right now for any expression that's present there. And it's going to give us a type object, which we can then use further to query information about the type. But first I'm going to give you a little quiz, because I need you to understand. I want you to understand that there are 2 types of nodes in an AST. You have statements and you have expressions. And statements in source code represent things like branching logic, things like function declarations, things like loops, and the difference between statements and expressions is that only expressions can resolve to a type. It does not make sense to have a type of a statement because that does not exist. It doesn't make any sense. So I want to ask you whether you think that variable is a statement or expression. Who thinks variable is a statement? Who thinks it's an expression? Yeah, yeah, everyone. So that was quite easy. Another thing that expressions can do is that they can be passed to other expressions without any exception. So, for example, when you are calling a function, you can pass any expression as an argument. What about return? Who thinks that return is a statement? And who thinks it's an expression? It's a statement, but it can contain an expression. So if we look at how the return is defined in the AST, you can see it extends a statement, but it contains a nullable expression because you can have return semicolon in your code, or you can return something and then put a semicolon in your code. So that's the nullable expression there. What about switch? Statement? Yes, it's a statement. What about assign? Statement or expression? Assign is an expression because you can put it into another expression. You can call a function and you can actually assign something inside the argument of the function. What about, and the type of assign is actually the thing that you are assigning. So the type of the entire assign expression is the thing that you are assigning on the right side. What about instance of? Statement or expression? It's an expression because the type of instance of is a boolean. You can also put it somewhere, you can also call a function with it, so it's an expression and it resolves to a boolean. It's either true or false. Type interface answers all questions about values and types. And it looks like this. It can tell you if a type accepts another type. It can tell you if one type is part of another type. It can tell you if two types are equal or not. It can give you a string representation, textual representation of a type, which is very useful for error messages and so on. And the isSuperType of method is one of the most useful methods that you can encounter, but also one of methods that are a little bit more challenging to understand. So I will try to explain it. So hopefully this room is not going to get any hotter. So isSuperType of. It helps if you imagine types as circles. So if we are going to imagine a hierarchy of exceptions, the biggest circle is going to be the throwable. And inside the throwable are all exceptions. So all exceptions are the green circle, it's smaller. And invalid argument exception is even a smaller circle inside the green circle. And isSuperType of answers questions about this. So we can ask, is throwable a supertype of exception? The answer is yes. And by the way, this method does not return a boolean, it returns trinary logic because there are three possible answers. And if we ask the other way, is exception a supertype of throwable? It's a maybe, because the type can fall either inside the green circle or outside of the green circle. So that's why it's a maybe. And again, if we ask if exception is a supertype of invalid argument exception, it's also a yes, because the entire invalid argument exception is inside the green circle. And right now you must be asking, what is this good for? For example, for a rule about instance of. So instance of PHPStan out of the box can tell you if an instance of expression is going to be always true or always false. So let's say that we are accepting an exception here, and you are asking, is this variable instance of trueable? So this is always true because trueable is super type of exception. So this kind of condition actually doesn't make sense in code, right? Because it's always true. If we are going to ask, is this variable instance of invalid argument exception? It's a maybe, because this might be invalid argument exception or it might be something else. So the middle condition, this one is the only one that makes sense in this code actually, right? And if you ask, is this variable instance of std class, super type of returns no, because it's never going to be true. It doesn't make sense. Std class is a distinct class, completely separate class from exception, so it's going to be no. And this method works between all types. So for example, you can imagine a type of all integers. So we have a blue circle of all integers, and inside you can imagine green circles of specific constant values. And it also works exactly the same way. So now, second demo time, we are going to write our custom datetime rule. So I will reset all of this. And we are going to have two datetimes here. And we want to report this. And we can also throw in something else. And we will not want the rule to report this problem. Okay, so we will create datetime comparison rule. PHPStan still works, perfect. It's so random, like it's sometimes forgets it in the middle of the day, but for no reason, and I have to invalidate the caches. But fortunately today it works. But it forgets to add this use. I have no idea why. But at the same time, it adds a use that's actually not used here, so I don't know. All right, so we are going to use the same trick here, because we don't know the name of the node. And we are going to register our rule. And we can run it on test. Nice. So again, we can kind of follow the structure of the file. Namespace, use, class method, fully qualified names, those are these type hints. And finally, we have identical here. So that's what we are interested in. 3 equal signs is identical, 2 equal signs is class named equal. So we want identical. We will also use generics here so that it auto-completes. And now it executes only twice for the two comparisons that we have here. All right, identical extends binary operation. And all binary operations have a left side and a right side, and both are expressions, which means that we can get types of these expressions. So left type, and now we have to think about the correct way how to ask about this. So what datetime classes, datetime and datetime immutable have in common? They have a common interface called datetime interface, and it's actually the biggest circle around these two classes. So that's actually what we will want to ask about. I can also show you, like, in the PHP documentation. Class datetime implements datetime interface. Class datetime immutable also implements datetime interface. So we will create datetime interface. That's new object type. And the correct way to ask about this is if is left side datetime, and we are going to ask datetime interface is supertype of left type. And now we have three possible states. So it's either a no, maybe, or yes. And what's an example of a no? Tell me.
Exception.
What isn't a date time? Yeah, for example, exception. Something else?
String.
String, integer, null, things like this. So what's a maybe? That's hard, right?
Datetime immutable.
No, that's a yes.
Object.
Object, yes. Mixed. And also, for example, a union of datetime or null. Yeah. And yes is datetime interface, datetime immutable. So this is nicely going to cover these three classes. There are other ways. As I said, every framework offers you multiple ways how to do something, and usually one is more correct than other. So you have multiple ways how to ask about this. For example, you could get class reflection representation of this type, and you can, for example, list the classes that you are interested about, but it wouldn't work, for example, if you could extend these classes. So, for example, it wouldn't work for the carbon class that extends datetime, for example, and things like that. So I think that this nicely covers all of the cases. But when you are writing a rule, you should always think about, like, what about the maybe? Like, maybe we don't want to allow object or mixed as well. So that's what you should think about. And I will copy this for the right side. So if left side is not yes, and we are going to return early. If the right side is not yes, we are also going to return early. And now we can return the error. Or I can between is not allowed, and I can make the string representations of these two types. So it's describe, and now it wants something called verbosity level, which is like a different level of detail of describing a type. So, for example, if you have a constant integer of value 1, you might be interested in exactly the value, number 1, or maybe int is all you need for the purpose of your error message. So that's the verbosity level that you can choose here. Right now, type only is sufficient for us, and the right type also the same. And now we can run it, and it works. Line 13. Okay. So, anyone has any questions up until now? Okay, so we can continue. I have more ideas for custom rules for you that we are not going to implement, but you can. It's just an inspiration of what you could do. One idea is that you should not allow creating new object when the class in question is already a registered DI service, because it doesn't make sense, right? You should ask for it in the constructor. You should not create it by yourself. You can make your controller thinner by enforcing only a single action controllers with a single public invoke method instead of having one fat controller that handles multiple URLs, for example. In Symfony, you can extend from abstract controller, but it's not the best practice, so you can also disallow this. Another idea is that you should require named arguments for attributes, because it makes it much more self-descriptive. So when you are creating new attribute, and maybe it has multiple arguments, you can describe them with named arguments, and it makes it much more obvious what the string is for. And from security perspective, you can, for example, prevent SQL injection by detecting if you are using prepare statements properly, or if you are concatenating SQL queries like this, which makes you vulnerable to SQL injection. All right, I promised you to talk about virtual nodes, which are those special nodes from the PHPStan namespace. So the rule interface works well if you want to detect something that's present in the code, but it doesn't work that well if you want to detect something that's missing in the code, right? So for example, if a function is supposed to return a value and the return statement is missing, you don't have any node to hook your rule onto, right? So that's why PHPStan introduces specific virtual nodes for these use cases. So you actually can detect tricky situations in your code. For example, the first node that's invoked for each file is file node. And for example, it makes really easy to if you want a custom rule to enforce declare strict types =1 at top of each file, because without this virtual file node, you wouldn't be able to detect that. It would be really tricky, but with the file node, you can just check the first statement and return an error if the first statement is not declare strict types. So there are various virtual nodes for these cases. One thing that's still a little bit of a secret and a little bit of experimental is that you can implement auto-fixable rules. So can anybody guess what this fix does? I've hidden the error message so that it doesn't tell you, but you can probably tell from the callback.
Makes the class final?
Yeah. So if you want to enforce final classes, and currently your classes are not final, you can implement this callback. You can change the node, and when you run PHPStan with -fix, it will change the error. It will change the files where an error that supports this is called. So this is useful, for example, if you have written custom rectors. If you are writing a rector for something that's already reported by PHPStan as a bug, either a built-in rule or your custom one, it's kind of tricky to replicate all of the logic where the error is reported again in a rector, because you need to re-implement all the logic to reach the same place and have it run at the same conditions the error is reported. But this is quite an easy and lightweight way. If you are already in your custom PHPStan rule and you want to implement an auto-fixable logic, you can do it in PHPStan rule directly. This does not mean that PHPStan is replacing rector, because I'm not interested, and it's not PHPStan's job to implement all the framework upgrading rules that Rector has for moving between framework versions, or even like upgrading your PHP codes to newer PHP versions. I don't want that to be PHPStan's job, so I'm not aiming to replace Rector, but in some cases this is useful when you when you already have a custom PHPStan rule and you just want to make it auto-fixable. This is much easier. And even the creator of Rector welcomes this, so this is not any kind of anti-competitive behavior or anything like that. So, restricted usage extensions. These are useful, for example, for some architectural rules. So this is an alternative to a custom rule. This is an easier interface to implement, because, for example, if you want to restrict where a method can be called from, so for example, you don't want your controllers to touch a repository directly, you can implement a restricted usage extension, and it's much easier than to catch all of these situations in a custom rule. This interface accepts a method, reflection, and a scope, and you can just write the logic, is this method allowed to be called from this scope, and it's much easier. So I refactored PHPStan deprecation rules to use these extensions, and I also implemented rules for @internal php.tag in PHPStan using these extensions, so they work really well. And you have extensions for methods, functions, properties, constants, everything like that. You can also have an interface that aimed at restricting where a class can be referenced from, and this interface has one more argument, which is called location, and that's because there are a lot of locations in your PHP code where a class can be referenced. I counted them and I implemented them all, and it's 27. And it's a lot of like native places in your source code that can reference classes, but there's also a lot of PHP.tags that can reference classes. So if you want to restrict where a class can be referenced from, for example, because it's deprecated, because you are not supposed to use it, you can implement this interface. And it actually, this class, besides referencing like all the places, can also make it easier for you to create an error message and an identifier for all these places without hard coding all of these places in your extension. All right, collectors. Collectors are really useful. So PHPStan custom rule can only sees a single place at a time, which means that it's kind of difficult or maybe even impossible to implement a logic that's supposed to look at multiple places at once, because even if you are like collecting all of the information in a single rule, it does not have the full picture, because PHPStan is parallelized and one process, one thread does not see all the places at once. But you can use collectors. So for example, if you want to detect unused code, if you want to detect that code, you can use collectors for that, and you would implement one collector for collecting declarations, then you would implement another collector for collecting usages, and in the end you see all of these collected information at once at the end of the analysis, and you can decide which places should be reported as an error. It's those places where it's those declarations that don't have any usages, so you can report them. Of course, you can write unit tests for your custom rules. We don't have time to look into it today, but you can check it out in documentation. And all of the core concepts that I touched upon today, which are abstract syntax tree, scope, type system, reflection, and dependency injection and configuration, because I was registering the rules in the phpstan.neon, so that's configuration. You can read all about them in the documentation under developing extensions and core concepts, and you can also refresh your memory when you will try to write a custom rule under developing extensions and custom rules on the website. So we just spent almost an hour learning about how to write custom rule. So I wouldn't say it's the hardest thing in the world, but there's still a learning curve to it. But I have quite a good news. You can just ask ChatGPT to do it for you. So I tried it, and surprisingly, it works. It works pretty well. It probably saw PHPStan source code, so it can quite well reason about it. So I just described what I wanted to do, and it did a pretty similar job to what I achieved. So the rule worked well. It also tells you how to configure it, how to register it, and it even generated a test case. So it's really important to know how to write custom rules in order to be able to review generated code. And it's also very important to analyze your custom rules with PHPStan because it can point out mistakes. And but if you don't know at all how to start, you can start with AI generating the first draft for you. So that's pretty good news. There are some awesome third-party extensions which you can check out. PHPStan rules, that code detector, which makes use of the collectors, which I was talking about in a really good way. There's PHPStan DBA extension. I think I actually have a slide about it a little bit later. So this extension, PHPStan to do by Markus Stab, is about checking to-do comments in your code. So if you have a to-do comment with a date, PHPStan is going to fail after this date. So you know that you need to do something about this to-do if it's no longer relevant after this date. If you're not yet using that code detector, it's really awesome. It's really world class. I was doing some research and I didn't find a tool for any other language that would go to such depth about detecting that code. So if this extension for PHPStan is going to tell you that some piece of code is safe to delete, you can be pretty sure that it's safe to delete, and it's very customizable. You can make it understand even a custom framework code. So, for example, if your method is magically called from outside from your framework, you can mark it as used, so it does not have any false positives. It's really awesome. I recommend you to check it out. And there's also the DBA extension. So, if you have SQL queries, SQL strings in your code, this extension is going to read them and is actually going to check them against your database with some kind of explain statement or something like that. And it will make PHPStan understand what's exactly going to be returned from database. So if you then ask about something that you actually did not select, PHPStan is going to point it out. And of course, it's going to know about parse errors and unknown columns in your SQL queries. And there's much more. You can check it out at phpstan.org, user guide, extension library. And you can find even more on packages. So if you search for PHPStan, you can filter on the right side by PHPStan extension. And you can look through all of the custom rules already available, because your idea for a custom rule might already be implemented by someone else on packages on GitHub. All right, that's all from me today. Thank you very much for your attention. If you have any questions, I'm not sure we have time for them now, but you can visit me later at my table with the elephants in the sponsor area, and you can come with your project. I can help you with performance, config issues, slimming down your baseline. Maybe we can pair program a custom rule together, anything you would want for the rest of today. And if you will try to implement something later and you run into issues, you can open discussion on GitHub. Thank you very much.